So here are the answers to the questions on proportion. Question 1 was, y is proportional to x when x is 4, y is 12. Find the equation linking x and y and complete the table. Well, if y is proportional to x, that means that the relationship is y equals something times x, y equals k times x. Now we know values of x and y, 4 and 12, so we can put those in. 12 equals k times 4 when x is 4 and y is 12. And from that we can work out what k is. Divided by 4, k is 3. So the relationship between x and y, well, we worked out that generally it was y equals something times x, and we've just worked out that that something is 3. So the relationship is y equals 3 times x. And once we've done that, we can fill in the table of values. There it is. Question 2. Y is proportional to x. So once again, it's y equals something times x. When x is 2, y equals 10. So we can put those values of x and y in and get 10 equals k times 2. And from that we can work out that k is 5. So the general relationship y equals k times x becomes y equals 5 times x now that we've worked out what k is. So the relationship between x and y is that y equals 5 times x, and now that we know that, we can complete the table. And there it is once again. Question 3, y is proportional to the square of x. So this time, it's going to be y equals something times x squared, the square of x. Again, we've got two values, x and y, so we can put those in. So 32 equals something, k, times 4 squared. 4 squared is 16, so 32 equals something times 16, and it's easy to work out that that missing value k is 2. So the relationship becomes y equals 2 times x squared. And now we know the relationship between x and y, it's easy to fill in the table. 2 times 1 squared, 2 times 1 times 1 is 2, 2 times 2 squared, 2 times 2 times 2 is 8, 2 times 3 squared, 2 times 3 times 3 is 18, and so on and so on. Question 4. Y is proportional to the cube of x. So this time, y is going to be something times x cubed. Y equals k times x cubed. Again, we'll put in the values that we know. So we'll get 4 equals something times 2 cubed. 2 cubed is 8 because it's 2 times 2 times 2. So we've got 4 equals k times 8. And it's easy to work out from that that k is a half, 0.5. So the relationship y equals something times x cubed, we've just figured out that that something is 0.5, so the relationship is y equals 0.5 times x cubed, and once you've done that, it's easy to fill in the table of values. And just remember when you're doing the table of values that you have to do the cubing first and then the times 0.5 afterwards. So for example, when x is 6, y is 0.5 times 6 times 6 times 6. You don't want to end up with the 0.5 part getting cubed along with the 6. Question 5. Q is proportional to the cube of P. So a very similar question. Q equals something times P cubed. We know two values of P and Q, 2 and 6, so we can put those in. So 6 equals something times 2 cubed. 6 equals something times 8. It's very easy to divide both sides by 8 and figure out that the missing value k is 0.75. So k is 0.75, and the relationship between q and p is that q is 0.75 times p cubed. So that's the equation linking them, and then it says find the value of q when p equals 10. So when p equals 10, well, we just put 10 into that equation, and q is 0.75 times 10 cubed, which is 750. Question 6. W is proportional to the cube of V. Very similar again. So W is something times V cubed. We've got some values that we know. We can put those in. And having put those values in, we can work out what K is. In this case, K is 0.8. So the relationship between W and V is that W equals 0.8 times V cubed. So that's the equation linking V and W, and it says find the value of W when V equals 10. So once again, I'll just put 10 into there and find out what W is, and it comes out to be 800. Now in question 7, we've got one that's inversely proportional. So in this case, y is going to be something divided by x. We've got two values for x and y, so we can put those in, and we get that 6 equals something divided by 3, and it's very easy to work out from that that the missing value is 18. So the relationship between x and y is that, well, we started by saying it was y equals something divided by x, and we've now worked out that that something is 18. So the relationship is y equals 18 divided by x. That's the equation that links them. Then it says find the value of x when y equals 10. Okay, so we'll just put 10 in there instead of y. 10 equals 18 divided by something. Just cleared the page there. So 10 equals 18 divided by something. Well, to get rid of a fraction, multiply by the denominator, so multiply by x, and that gives us 10 times x equals 18. So x, find that by dividing both sides by 10, x equals 1.8. Question 8. Y is inversely proportional to x again, so y equals something divided by x. We've got two values, 5 and 4. So put those in and we get 4 equals something divided by 5, and we've got to figure out what that something is. In this particular case, it's a little easier than the last one because all we have to do is multiply both sides by 5 to get that the missing value is 20. So the relationship between them is that y equals 20 divided by x. And it says find the value of y when x is 100. So just put 100 in instead of x. Y equals 20 divided by 100. So that is easier than the last one because you haven't got to rearrange it. 20 divided by 100 is 0.2. So when x is 100, y is 0.2. Now, question 9. Y is inversely proportional to the square of x. So it's y equals something divided by x squared. When x is 6, y is 5. So let's put those two values in. So 5 equals something divided by 6 squared. And we can use everything we've got there to find out what that missing value k is. 6 squared is 36, so it's 5 equals something divided by 36. Multiply both sides by 36 and you get the missing value is 180. So the equation linking x and y is that y equals 180 divided by x squared. And then find the value of x when y equals 1.8. So we've got the relationship between the two things. Put in the fact that y is 1.8, so 1.8 equals 180 divided by x squared. Get rid of a fraction by multiplying by the denominator, so 1.8x squared equals 180. Excuse me. Well, we're trying to find out what x is, so let's divide both sides by 1.8, and we get that x squared is 100. So if x squared is 100, x must be the square root of 100, so x is 10. So when y is 1.8, then x is 10. Another part of the question, find the value of y when x equals 9. So again, take the relationship between the two things and put in the value that we've got. And we get that y is 180 divided by 9 squared, which is 2.2 recurring when you work it out. 180 divided by 81 is 2.22 recurring. Last question. D is inversely proportional to the cube of E. So we've got D equals something divided by E cubed. We've got two values of D and E, so we can put those in to try and find out what this missing value K is. So 5 equals something divided by 4 cubed. 5 equals something divided by 64. 4 cubed is 4 times 4 times 4, which is 64. So 5 equals something divided by 64. Multiply both sides by 64 to find out that the missing value K is 320. So the relationship between D and E is that D equals 320 divided by E cubed. And it says find the value of E when D equals 0.32. So we take the relationship between the two things that we've got, put in the fact that D is 0.32, and then try and rearrange that to figure out what E is. So we're going to multiply both sides by E cubed to get rid of the fraction, and we get 0.32 times E cubed equals 320. We're going to divide by 0.32 to try and isolate the E part, and we get that E cubed is 1,000, so E is the cube root of 1,000, which is 10, because 10 times 10 times 10 makes 1,000. Then another last part of the question, find the value of D when E equals 5. So this should be a bit easier because it involves less rearranging. D equals 320 divided by E cubed was the basic relationship between the two things. So if E is 5, you've got D equals 320 divided by 5 cubed, which is 320 divided by 125, because 5 cubed is 5 times 5 times 5, which is 125. So that comes out to 2.56. So when E is 5, D is 2.56. And that's the end of the questions.